Well, good afternoon, everyone. My name is Sandra Saenz, and this is Javier Trevino. And we just want to thank everyone for showing up for our presentation today. Unfortunately, our client wasn't able to show up. We got an email from her earlier today that she had a meeting that was going to kind of overlap today. But our project is entitled SEM Energy Data Analysis. Our agenda for today, we'll talk about our client company for a little bit, and then we'll define our project, and we'll move on into the analysis that we did along with our project, and we'll conclude with some recommendations for our client. So a brief background, Hunt Consolidated Inc. is a private group of entities based out of Dallas, Texas. And as I previously mentioned, they did start with oil and gas, but despite what people know them as, they also do have a big branch dedicated to power, and that is where SEM Hunt falls under. They're managed by the Hunt Mexico Group, and they are a subsidiary of Hunt Power. And essentially what SEM Hunt does is that they sell a system and service for energy efficiency for big retail stores in Mexico. Okay, so now defining our project, our goal was to analyze the large sets of energy consumption data of 3 department stores to generate results that will benefit both SEM Hunt and their clients. The 2 main questions that we targeted in our project were, are there any trends between the energy consumption and the different days of the week or months? And what are some forecasting models of energy consumption for each store? The tools we used for this project are SPSS, Excel, and Energy 360, which is the online portal for SEM, and that the data is recorded for each store every 5-minute intervals, and that's where we downloaded all of our data from. And we chose 3 stores, one Monterrey, Centro, Mexico City, Pittsburgh, Mexico City, Santa Fe, and Monterrey is actually a city in the northern part of Mexico, and Mexico City is centrally located, which later will play an effect into our roles. We also used 2 different sets of variables. First, the time variables that you can see to the left, and then we found a lot of other economic variables from INEGI and Banco de Mexico, which are both governmental agencies, so they're reliable resources for this information. So starting, we had to lay out a few assumptions before we started digging into the analysis, and they were that the sub-meters that were registering the kilowatt consumption into the Energy 360 was reliable and correct. Then that the data from the past will be similar to that of the future. For forecasting purposes, we were relying on the past data to come up with forecasting trends. And the economic variable data conversion that we had in a monthly unit, when we had to convert it to daily, we just allot that monthly data into the same number just repeatedly for each day of the month. And the holidays that we used were only holidays that were government issued. So if a company maybe had a different holiday, that wasn't included.
Okay, so for project analysis, we started using Excel. We had to use pivot tables in order to convert the 5-minute interval consumption data into daily and monthly units. We also used the pivot tables to calculate averages between the daily consumption and monthly consumption units. Answering the first question of our client, if there were relations between the variables and the dependent variable, which in this case is consumption, we found out that there were very weak correlations. We just learned that, we just saw that in Centro, which is the Monterrey location, there were some positive correlations and 2 moderate ones. The strong one was temperature. There's a strong correlation there, which is 0.68. It means that they fluctuate like in a similar manner. For the other 2 stores, there were both weak correlations in all the economic variables we chose. We also made the correlation for each day of the week and months to see if there were anything there. We got weak correlations, but then we decided to extend further our research and get the average daily consumption for, in this case, there you see 6 different charts, 2 from each store. In this side, you see the consumption here and an average daily for each day of the week. This is from Monday to Sunday. And in the other side, you see January to December. It's the average daily consumption. With this information, you can notice that comparing between the stores that on the weekends is the highest, the peak of the consumption, which means that like they all have that similar thing, but there are some differences. Like in the Perisur store, Friday are their biggest days, and Saturday for the other two are the highest consumption day. For the monthly, we noticed that on the second and third quarter are the highest consumption for the three stores. It's important. This information is important because they can use it to compare between the highest points and the lowest points and see what they're doing different, what's going on different, and try to make it more efficiently, try to make it smooth.
Okay, and now moving on to what we did in SPSS. This is a scatter plot, and this is a very simple scatter plot. It's just the raw kilowatt data over time, and I did forget to mention that we did choose data for 4 years, so from 2011 to 2014, and you can see the 4 different blocks of the years. So starting with the Centro location, you can see that there is the seasonality, and that it's repeated in the 4 different years. And what's also good to note about that store is that there is a seasonality, but there also is a decline in the trend. So that means that that's good, that the system is working and that they're reducing the kilowatt consumption, therefore reducing costs for their clients. And then moving on to the Perisur and Santa Fe, we actually had a little bit more of a struggle with this data because, as you can tell, there are a lot of small chunks of missing data and a lot of outliers as well. So it was hard to tell if there was something that had happened that day or if it was just a misreading from the submeter. And here we ran a few tests of the consumption versus a variable and see if there was some sort of correlation. And as you could tell from the previous slide, that there was a seasonality in the first graph that kind of shows it here, where we have the kilowatt versus temperature, and you can see that as the kilowatts are more consumed, the temperature also rises, so you can see the correlation there. And then we have the correlation coefficient of 0.69, which is good. You want to be as close as you can to 1. And then if you move down to the other two stores, you can see that the correlation coefficient is closer to 1, meaning that there isn't really that much of a correlation. And what we thought that specifically temperature had to do with the consumption is that regionally, Monterrey is in the northern part of Mexico that has a lot of fluctuation in their weather, versus Mexico City is more stable and there isn't much variance in their temperature. So we think that had to play with the different correlations of the temperature. We also ran a normal distribution test, and I will just talk briefly about the first one, and it's kind of like the same thing repeated for both stores. So in the first one, we have the respective chart that SPSS gave us all the statistical information about. And in Centro, the mean is about 90,000 kilowatts in consumption. So adding 1 standard deviation to both sides, it would have a range from 66,000 to 112,000 kilowatt per consumption. That would be 68% of most of it. And if you even added a second standard deviation, then you would move from 43,000 to 135,000. So this, we thought, could be useful for the predictive model of the SEM system, so that they could tell that if they had anything outside of that 95% or even 68%, then maybe they could have an alarm system that said that, we have different consumption, we have an outlier, what's going on.
Okay, so we decided to do a regression model for each store. This information hard to see, but I'm gonna explain it how it works. The important thing here is the R-square and adjusted R-square. For this particular store, we did got a good model. We tried different variables using one method and got to a model where the R-square is a good fit for the model, but we tried to decrease the number of variables so that we don't have too much trouble trying to predict what's going on next. This model, you can see the real values are the ones in blue one, and the red line is the predicted by the model, so it's pretty close. The ANOVA test told us that the F, it's good, it has good significance, the value is really low. So so it's good. And the coefficients we use are listed here, and it's important to see the p-value for each store. If it's lower than 0.05, it's good to use, because that's the probability of it being zero instead of the coefficient that the model is predicting to be. One of the things that can be useful with this model is that it can let you know, like using the coefficients of the variables, it lets you know, like for example, the first one, which is temperature, for each unit increasing temperature, the consumption will increase 98 kilowatts. This is for the second store. We did have some struggles. We did got a good F result and good p-values, but we weren't able to get a good R square. In this case, it's just 0.3, the adjusted R square. So it doesn't give us a really good fit. We believe that this is because of the huge variation in data that this store has. You can see that the blue line going up and down with a huge amount of variation. That affects the model, which is hard to do. There was a similar problem with the Santa Fe. Since there's also a big variation, it was hard to get a good adjusted R square, but we did got a good F significance, which proves the model is good, and the coefficients as well. We wanted also to do a forecasting method to predict what's going on. That way they can see if their stores are going like in a good direction on their consumption, or they're going they're increasing their consumption. In this one, for the first store, which is Centro, you can see quickly, well, the blue line is the actual values. The red one is the centralized moving average, and the forecast is the green one. We used the advanced time series method called ARIMA model. This allows us to predict using seasonality, irregularities, and trend components. They put it in the question. We wrote that model, which uses M moving averages and a simple linear regression, puts it together and gets a forecast. You can see there's a trend going down, and it looks like it's going to be predicted good for 2015. For the other stores, there's more of a struggle, but we did found some seasonality as well, but it starts increasing at the end, where it should start decreasing instead. The model predicts it's going to keep going with the seasonality, which we think the difference is because of wrong values in the data or missing data that are affecting the model. And for the last one, we can see also there's an increasing consumption, so it's not good. They should be decreasing it. We run the model as well, and we found that if they keep the things the way they're doing it right now, they will keep increasing their consumption, of course, until a limit, but that's not good. They should look for ways to decrease that value.
So finally, the recommendations. We recommend to implement more forecasting techniques, any of these or all of these if they can, to make it more accurate, with external values such as like the time values that we had, or even economic variables. The Perisur and Santa Fe stores in Mexico City, the variability just was great compared to the ones in Monterey, so maybe take a look at those two specific locations to where they're not consuming more than they should, and they should be declining like the Centro location. And to one of the holidays that we saw that Easter was low, and a few other holidays that are like the typical that you would assume that the stores would be closed. But one like anomaly in a spike was 2 weeks before Christmas. There was a spike in the energy consumption, so we thought that maybe they could integrate that to predict future energy consumption. Are there any questions?
Questions? What did you find most challenging in the project?
Missing data.
The missing data, definitely. The missing data, and then having a lot of economic variables being quarterly and then some monthly versus having 5-minute interval data or daily weather data. So just trying to combine all of the different.
So how did you handle the time variation?
So time variation, we did We used the pivot tables to add up all of the energy consumptions because we had close to over 600,000 rows of information. So into daily, and then we used that to compare it to weather, for example. But then when we were comparing it to monthly information that we have with economic variables, we would just get another sum of all the data and then compare it to the monthly variables. But then when we wanted to compare everything the same way, we found that the commonality would be monthly. So when we would have a quarterly economic variable, we would just drag all the information and assume that that would be consistent, or at least an average of every month. So that's how I guess monthly was like the time unit that we use across.
Other questions?
Were you able to visit these locations?
No, we weren't, but we're familiar with the kind of department store, so,
Okay,
yeah.
oh, they're department stores.
They're
Okay,
department
that makes
stores.
sense.
All right, thank you very much.